Assalamualaikum and very good day to everyone. Today we are going to present one of the subtopic from chapter 2, which is Green's theorem. So, before we start to explain more about this Green's theorem, let me introduce our group members. First is Ahmad Syafiq bin Ahmad Nizam. The second one is me, Ifah Hidayati binti Zainal. And the third one is Nur Amira binti Amizuddin. And we are from group CS2495A1. So, I'm going to explain about the introduction. The first one is about the history. Green's theorem is due to George Green, an 18th century British mathematical physicist who wrote an essay on the application of mathematical analysis to the theories of electricity and magnetism. Next is I'm going to explain about the definition of the Green's theorem. Green's theorem is mainly used for the integration of the line combined with a curved plane. This theorem shows that the relationship between a line integral and a surface integral.
Alright, next we're going to statement of Green's theorem. Alright, let's C be the positively oriented, smooth and simple closed curve in a plane, and R be the region bounded by the C. If fxy equals to pxy plus qxy is a vector field where pxy and qxy are functions defined and have continuous partial derivative in an open region containing R, then f dot R equals to v dot f kdA. The more popular form of Green's theorem is, as you can see at the slide, p dx plus q dx equals to integral r delta q over delta x minus delta p over delta y dx dy, where the path integral is traversed counterclockwise along with c. Alright, we move to area. From Green's theorem, it is possible to find the area of the closed curves. Green's theorem formula state that p dx plus q dy equals to delta q over delta x minus delta p over delta y dx dy. If in the formula delta q over delta x minus delta p over delta y equals to 1, then we have p dx plus q dy equals to 1 dx dy. Therefore, the line integral defined by Green's theorem gives the area of the closed curve. We can write the formula as a equals to x dy and a equals to 1 over 2 x dy minus y dx. Alright, I'm going to explain about the application of Green's theorem. Green's theorem is the case of Stokes' theorem where the surface is completely in the plane but in simple shapes, particularly in the vector field of a plane. It is also used to compute area. The tangent vector to the boundary is rotated 90 degrees in a clockwise direction to produce the divergence vision of Green's theorem, which turns it into an outward pointing normal vector. Alright, I'm going to explain about mathematical solution for question 1. As you can see, the case study for question 1, an organizer from a company in Kuala Lumpur wants to hold a memorial concert in Kejalil National Stadium. They estimate about 50,000 attendees during the event and their team wants to fully utilize the whole stadium. However, they have a problem that roof at first quadrant of the stadium is leaking and needs to be fixed immediately. The region of the stadium is shown in figure 1. Verify Green's theorem x square y dx plus xy square dy, where C is the roof at first quadrant of the stadium, the region bounded as indicated in figure 1. Alright, this is technically roughly we draw, and this is the first quadrant of the roof at National Stadium Kejalil. Alright, I'm going to explain to you about mathematical work for question 1. Okay, we use p dx plus q dy equals to qx minus py. Okay, we move to right hand side first, and from equation x square y plus xy square, we determine that p equals to x square y and then q equals to xy square, and then we find py and qx, and then we get py equals to x square and then qx equals to y square, and then we insert to the equation which is qx minus py dA, and we get x square minus y square dA, and then we convert to the polar coordinate, which is clockwise, and then x equals to r cos theta and y equals to r sin theta, and then for r square equals to x square plus y square, and then finally we get r cube cos square theta minus r cube sin square theta dr d theta, and we insert the limit for integral, which is for dr pi over 2 0, and then for theta 3 1. Okay, and then we integrate negative 1 over 4 we integrate the equation, and then for finally we get negative 20 sine 2 theta over 2, limit theta over 2 0, and final answer we get 0. Alright, next we move to left hand side. We start with C1, the area from 03 to 30. The equation is x square plus y square equals to 9, and then we convert to polar coordinate first. X equals to 3 cos theta, and then y equals to negative 3 sin theta, and then we find the derivative. For the x we get negative 3 sin theta d theta, and then for the y we get negative 3 cos theta d theta, and then we insert to the equation x square y dx plus xy square dy, and we get for limit 0 from 0 to pi over 2, we get 3 cos theta square minus 3 sin theta minus 3 sin theta plus 3 cos theta minus 3 cos theta square minus 3 cos theta d theta for the derivative, and then we integrate, and the final answer we get 0. Alright, we move to C2 from previous slide, from point 30 to 10, and x equal to x, and then y equals to 0, and we find dy equals to 0 dx, and we insert to the equation x square y dx plus xy square dy, and the final answer for C2 we get 0. And then we move to C3. The point is from 10 to 01. We use the equation x square plus y square equals to 1. We convert to polar coordinate first, and then we use x equals to cos theta, and then y equals to negative sin theta, and then for the x we get negative sin theta d theta, and then dy we get negative cos theta d theta, and we insert to the equation x square y plus xy square, we get limit pi over 2 0 cos theta square minus sin theta plus cos theta minus sin theta square minus cos theta d theta, and then for the final answer we get 0 for C3. And then we move to C4. From 01 to 03 we use x 0 and y equals to y, and we get dx equal to 0, and then we insert to the equation, and for final answer we get C4 equals to 0, and we add all of the point for C1, C2, C3 and C4, and for final answer we get 0 for C value.
I will be presenting the maple solution for question 1. Firstly, type and restart with student. Next, let m equals x square y and n as xy square. Then we let a as the differentiation of n with respect to x minus differentiation of m with respect to y. We let b as the value of a, which is negative x square plus y square. Then we let x equals r cos theta and y equals r sin theta. We let c as the value of b, which is negative r square cos theta square plus r square sin theta square. We let d equals negative double integral value of c multiply with r equals 1 till 3, theta equals 0 till pi over 2. Then we get the value of d, which is 0. To visualize question 1 in the form of graph, firstly type in restart with plots. Next, type in a equals implicit plot x squared plus y squared equals 9, x equals 0 till 3, y equals 0 till 3. Then we let b equals to implicit plot x squared plus y squared equals 1, x equals to 0 till 1, y equals to 0 till 1. And then we type in display a, b to obtain this graph.
Next is I'm going to explain about the mathematical solution for question 2. As shown in the slide, this is question 2, which is evaluate y squared minus x dx minus 4y dy using Green's theorem. So, for the mathematical work for question 2 is first we need to find the line segment from point 24 to point 06, which is we use y equal to mx plus c, and then we get y equal to negative x plus 6. And we also need to find the line segment from point 06 to point negative 24, which is also use y equal to mx plus c, and then we get the line segment is y equal to x plus c. Then we need to find the value for m and value for n from the equation, which is m is y squared minus x and value n is 4y. And then we differentiate m respect to y and we get 2y. And we differentiate n respect to x and we get 0. Then we substitute it into the formula of the Green's theorem. And for the dA, you can consider it as dy dx or dx dy. And for this calculation, we decide to use dy dx. Then after we substitute it into the formula, we have double integrate of negative 2y dy dx, which is the range of y is from x squared to x plus 6, and range for x is from negative 2 to 0, plus double integrate of negative 2y dy dx, which is the range for y is from x squared to negative x plus 6, and range for the x is from 0 to 2. And then we continue to integrate as usual, and we get the answer is 88.53.
For question 2 maple solution, firstly we type in restart with student. Next, we let m equals y squared minus x and let n equals negative 4y. Then we let a equals double integral of differentiation of n with respect to x minus differentiation of m with respect to y. Y equals x squared till x plus 6, x equals negative 2 till 0. Then we get the value of a, which is negative 664 over 15. After that, we let b equals double integral of differentiation of n with respect to x minus differentiation of m with respect to y. Y equals x squared till negative x plus 6, x equals 0 till 2. Then we get the value of b, which is negative 664 over 15. After that, we add the value of a and b, which is negative 1328 over 15. To visualize question 2 in the form of graph, firstly type in restart with plots. Next, let a equals plot x squared, x equals negative 2 till 2. Then let b equals plot negative x plus 6, x equals 0 till 2. Then let c equals plot x plus 6, x equals 0 till negative 2. After that, Let E equals display AB. Lastly, type in display EC and we get this as the graph.